If you have worked in complex data projects or Apache Hive, you must be familiar with user-defined function. They help us to write reusable and modular SQL code. They are written once and called in many places in your SQL logic. If you look at this simple example, the SQL statement has an inline logic, and if you have to apply the same logic in 10 more places, we have to write the same set of case statement again and again. If changes need to be done in future for some reason, it has to be done in all those places. And that is a time-consuming and expensive operation. If we have to bring reusability or modularity, we can introduce UDFs, or we call them user-defined function. And by doing that, not only my query looks simpler, but it also brings a lot of manageability and reusability. Every other database and data warehouse system has user-defined function. So what's that new we need to learn in Snowflake, and how different they are from other databases or data warehouse platforms? At very high level, we all understand the user-defined function, and there is nothing new in that. But let's go through this question, which might bring the differences when we compare other databases and warehouse systems. And this chapter will provide detailed answer to all these questions. What is secure UDFs and what role does it play? How to write JavaScript UDFs and their limitations. Can I write UDFs in Java programming language? Does Snowflake support UDAF, or we call them aggregated functions? How to invoke table functions? Will they be part of select expression, or it looks a little different? Does Snowflake support function overloading? If so, how? So stick with this video till the conclusion if you want to gain a thorough understanding of Snowflake user-defined function. Alongside theory, I will also demonstrate everything live. So welcome back to my channel Data Engineering Simplified, and to this real jumpstart course for Snowflake data professionals. The last 20 episodes in this series already covered history to architecture, data loading, micro-partition, time travel, cloning, stream, task, stream and task together, role and role hierarchy, stored procedure, end-to-end ETL, and many more important concepts. This is episode 21 part 2. This episode is divided into 3 parts. Part 1 already covered stored procedure, and part 2 will primarily deep dive into user-defined functions and how even Java and JavaScript developer can code to build complex business logic in Snowflake. We will see how to build Java function and deploy them as UDF. We will practice everything using Snowflake free trial edition and have hands-on exercise to cover all these concepts listed in this slide. Before we move next, let me ask this. Do you want to have mastery in the Snowflake Cloud Data Warehouse? I believe you should be, because there are many amazing opportunities available if you are familiar with the Snowflake Cloud Data Warehouse system. I have been adding a lot of great content to help the Snowflake community. The response I received from my audience much exceeded my expectation. People are getting certified on their first attempt and scoring nearly 100%. My free content is used by data engineers, data lead, architect, and even data managers. You don't need to buy any expensive courses. Check my playlist. It includes almost everything to make you a successful Snowflake data professional. So, if you find something useful in this content, please press the like button. Leave your opinion in the comment section or send me a direct message on Instagram. Before we take a deeper look into the user-defined function, let's write a simple function and understand its SQL context using Snowsite Web UI. I'm going to create a simple order table and insert handful of record, and using this order table, I will demonstrate the functions. My order tables got created successfully. I am inserting handful of record, and I see 4 record got inserted. Let's check the record first. So I can see I have order ID, customer ID FK, item ID FK, retail price, purchase price, sold quantity, and the country code. So these are my field, what you can see it here also. Now I am going to create a function called calculate profit. By using this retail price, purchase price, and sold quantity, I can apply a simple formula and calculate the profit or loss. So this is my simple calculate profit user-defined function, which takes retail price as an input parameter and purchase price as another input parameter, followed by sold quantity as another input parameter. It returns a number and then I have a comment. This is a simple profit calculator. So this is a very simple function. It simply takes this input parameter, applies a formula, calculate the profit or loss, and you can have only one SQL expression in this body. Another important thing is that in a stored procedure, we have seen that every SQL statement has to end with a semicolon. In this case, you don't have to use semicolon. So my function is created successfully. Previously, I have done select star from the order tables. This time I am doing select item ID, retail price, purchase price, sold quantity, followed by calculate profits. This calculate profit is nothing but a function call where I'm passing 3 parameters and giving a name called profit from UDF. Okay. I can see my profit from UDF is calculated based on this 3 input parameter. A very simple one. Alternatively, I can put that calculation also as a part of SQL expression directly without really calling the calculate profit. It also brings the same result. Now we'll see slightly complex function and understand that how does it really bring simplicity. So I have another function called country name, which takes the country code and it converts the country code into country code followed by the country name. I have one single SQL statement. Let me create this function for you. So my function country name created successfully. Now here I am calling this function calculate profit and country name by passing the input parameters and running it. And I can see the result here: US, USA, IN, India, JP, Japan. Alternatively, if I have to really embed that logic inline, then my SQL code looks like this. So here I am embedding the entire calculation in a single line, and I am also embedding this entire case statement along with this SQL. This will also bring exactly the same result. Yes. This particular SQL statement is taking around 13 to 14 lines. However, if you see, this looks relatively cleaner and more modular. If I have to use this logic in many places, it will be the repetition of the code, and I can wrap this repetition in a single function and then call the function from wherever it is required. Now I would like to understand how to use show and describe function features to understand what exists and how do they look like. So the first command I'm going to execute called show function, and this will bring not only the user defined function but all the inbuilt function available in my Snowflake instance. Let's run this command. So I can see I got total 612 function available in my account, which includes inbuilt as well as user defined function. There are other fields like whether it is aggregated, whether it is ANSI standard, what is the number of argument, how the argument looks like, what is the description, catalog name, is table function, valid for clustering, is secure, external, what is the language. So when you run show function, it will bring all those columns, which will help you to analyze if you have a lot of function available in your account. What if you want to see functions within your database or within your schema? Right now, I have only one database and one schema, so number would not change. So whether it is a built-in function or user-defined function, all are available within my ttips UDF schema. So let's run this statement. I got the same result, 612, good. Now, if you have a lot of schema and each schema has a different number of functions, you can use this command. It also brought the same result, 612. What if I am looking for a specific function? In that case, I can use a keyword called like along with show function, and this is how it looks like. So it brought me only one entry called country because we have written only one country underscore name function. This belongs to schema UDFs, and my catalog name is ttips. Good. If I have to look for an object which has a word profit, let's see. So I have two functions with name calculate profit. Since I have created two functions, and how do they look different? So they are different with respect to their argument. Here you see calculate profit, the name looks exactly same, but the data type are different when it comes to the argument. Now, if I have to describe a function, I can use describe function keyword followed by the function name. In this case, the function name should also have parameter data type. It will complain. Let's run this. So it says that this function doesn't exist because I have to specify the parameter name along with the function name. This brings a result even if I remove this part because I am already having a context set. This brings the same result. It says my signature takes one input parameter of varchar type. The return is varchar and the language is C. And this is the body. If I want to see the full body, here I can press this minimize and expand button to get the value. We have seen how this show function works, and if I have to filter any specific type or a column, then how can I do that? For that, I have to use a result scan, which we have seen in our previous video when we were discussing about stored procedure. So here first I will run the show function, use this query ID either using the keyword last query ID or by replacing it with a query ID. So let's run this function. My query ID is copied. Let me replace it everywhere. Now when I run this particular select statement, it will bring the same result what I have got in line number 122, but in a form of a table. So I got the data in a form of a table, perfectly fine. Now if I want to order by 4, which is number 1, 2, 3, 4 built-in, use order by 4. Now I got all my built-in UDF functions on the top. I can also say built-in function equals to no or a yes. Good, so I got this detail. Now, if I want to specifically see these functions, I can say, do they exist, and run a command like this, and I see this result. I can also have little more complex query like this. It gives me how many SQL functions I have it, how many JavaScript function I have it, how many Java function I have it, whether they are built in and what is the schema they belongs to. So this is how I can use show function, use result scan, and I can apply different kind of where clauses and group by to build this summary. We have seen a very simple user-defined function, how it works, and understood how to list and describe a function. Now let me walk you through the UDF construct and explain what all are optional and must parameter and default values if those parameters or keywords are not specified. Here is a simple UDF construct. The object creation start with a standard keyword create or a replace function followed by the function name. Within your context, the keywords like or, replace, comment are optional. After the keyword function, you have to give function name followed by the input parameters, where parameter name must be defined first, followed by the data type for that parameter. In this case, the function name is country name and the code is the first input parameter and it is of data type string or varchar. A user-defined function always returns a value and the return keyword along with the return data type is must in the definition section as highlighted. The above example returns a single column value. We can also return a table and that will be elaborated later in this video. Single column or a single field user-defined function is called scalar function, and if it returns a table like rows and columns, then they are called table functions. Finally, we see the as keyword and the $sign. And within the $sign, you must have your SQL body. One point to remember, the expression defining the UDF should not contain a semicolon as a statement terminator, else it will end with an error. The default language for function is SQL if not specified. If you are writing JavaScript based function or Java based function, in that case, you have to specify JavaScript as a value or Java respectively in the definition. For a security or a privacy reason, you might not wish to expose the underlying tables or algorithm detail for a UDF. With secure UDF, the definition and detail are visible only to the authorized user. The construct looks like this. You just need to add the keyword secure while creating the function. The secure UDFs are also used for data sharing feature. Non-secure UDF cannot be shared, and that's why secure UDF are very important when it comes to the data sharing and data exchange. There is a scenario where you expect your UDF should not return null. In such case, you can use this parameter. We had seen this option in the stored procedure episode 2. This parameter specifies whether function can return null values or must return only non-null values. This feature is not applicable as of now for SQL language. This is only applicable for JavaScript. Now one more parameter which you can specify called return null on null input. Now when you indicate this parameter, your function will always return a null value if your input values are null. Now there are cases if you have a specific requirement where you expect a null value to return or the body should not even execute. In that case, you can specify this parameter, and we have seen this in our previous episode while building stored procedure. I am back to my web UI. Let's change the context quickly. So this is my simple SQL UDF, and here you can see in the line number 9, the language is equal to SQL. Okay, let me run this simple function. It got executed successfully. So even if I do not specify language equals to SQL, the default value for language is SQL. Now let me create a JavaScript function called simple.js UDF, and on the line number 19, you can see the language is equals to JavaScript. Let me create this function. If you are creating a Java function, then you can use language equals to Java. We will cover the Java function later, so I'm not executing it. Now, if I call both the functions simple SQL UDF as well as simple JS UDF, let's see what does it bring. So this is how my result looks like: simple SQL language and simple JavaScript language UDF. If you notice, both of them are having a single return statement. An SQL expression does not end with semicolon. Here, I am using a return keyword. JavaScript functions are having a different grammar, and you can write a lot of if-else condition within the JavaScript function. Now, if I run show functions like simple, let's see what does it bring. We will validate the metadata. So I have two functions starting with name simple, like simple JS UDF and simple SQL UDF. Both are under UDF schema, not inbuilt. Language for one of them is JavaScript, and for second it is SQL. Good. When I describe the simple SQL UDF, let's see what result does it bring. So here it gives me 4 rows. Signature, it's empty. Return value is varchar, language is SQL, and body is simple select statement. When I execute the JavaScript function, it brings total 6 rows. So this is common, language is common here, JavaScript. There are 2 additional values which are visible, called on null input and volatile, because these things are not applicable for SQL function. These are applicable only for a JavaScript function. And next, we will focus how the not null specification works with SQL as well as JavaScript function. So my context got changed. Now I am creating a function called not null SQL function. The language of function is SQL, and here along with the return type string, I am specifying not null. It means that if I am returning select null, it should complain. Let's create it. It got created successfully. Now when I run this SQL function, let's see its behavior. It is actually returning a null value, which shouldn't be the case, right? However, we have seen when we describe this SQL function, it says that it's not null, but during the execution, it actually returns a null value. Let's try to understand this behavior in JavaScript. So here my function, JavaScript not null JS UDF, which is written in JavaScript language, it is returning a null value. Let's create this JavaScript function. Got created successfully. Now let's run this function. So it says that null result is non-nullable column. So this complaint saying that null result in a non-nullable column, it means that it is expecting a null value. However, we are returning a null value. Let me fix it. So now it is working fine. So this is the difference of this parameter. If you define not null as a specification in SQL function, it has no effect. If you define the not null in JavaScript, it will enforce you that the function should return a not null value. Good. Now let's describe and understand. When you see the return, you can see this specification is available here. This is very similar to strict keyword in stored procedure, which we have covered in the previous chapter, chapter 21.1. If you have not seen, this is the link here and you can go and watch. Now we are going to discuss the secure function in action. In my context, I am creating my first secure function. The name of the function is that secure underscore SQL underscore UDF. And here is a keyword secure. No changes are required. This is a very simple demo function which says select, wow, my secure Scalar function UDF worked. Secure function is created successfully. Now when I run this, let me run and see the behavior. Okay, perfectly fine. Now I am creating another secure function with JavaScript language. Specific change, it is only saying that JavaScript UDF, and let's understand the behavior together. So one says I am a SQL UDF, another says I am a JavaScript secure UDF. Okay. I describe this function, let's understand where this parameter is captured. So this parameter is not captured anywhere in this. However, when you show function will capture whether it is secure or not secure. So I got the result, and now let's see what is the secure flag says. So here, if it is a secure UDF, this flag will become true for secure UDF. Okay, so this is how you can understand how many secure functions you have it and how many standard functions you have it. Now to understand what is the real meaning of the secure function, I have to give a usage grant to a less privileged user and trying to see whether this less privileged user is able to view the content of the SQL or not. Let me select my current role. So my current role is system admin. And when I'm invoking this function as a system admin, here I can see my system admin. Now I am invoking both the UDFs using a select statement. And I'm able to see the result. Now I am creating a non-secure function called non-secure UDF. This is a JavaScript UDF and it says that security breach not secure. So my non-secure UDF is created successfully. Before I switch my role to the public role, I will give a usage access to these functions to the public role. If you have not seen my role and role hierarchy videos, please refer the link in the description or in the video card above. Very, very important chapter. I request everyone to watch that video. So before I allow a user to access my function, which is created by the admin role, I have to make sure that the user or a role having an access to the database as well as the schema. So this is what the grant usage you will provide it. Now I am going to give usage grant to these three different functions to the public role. The statement executed successfully. I also want to make sure that the public role has an access to the compute warehouse. So all those usage grant is given to the public role. Now I am going to switch my role to the public role and let's see what happens. To switch my public role in the same worksheet, I have to click here and switch my role. So now let's validate what is my current role. So my current role is public. Now let's see whether I can use compute warehouse or not. Yes, my compute warehouse is accessible from public role. Good. Now if I try to run this command, let's see what result does it bring. It should bring exactly the same result. Wow, so it worked. So this is SQL UDF, this is JavaScript UDF, and this is non-secure UDF. Now when I try to describe these two functions, which is a secure function and which is a non-secure function, let's see what result does it bring. So here first I'm trying with a non-secure function because it should work. So I am able to see all the content, what input does it take, which is perfectly fine, whether it is JavaScript or not, called on input null. So these specifications are visible to me, which is perfectly fine. And here the body is also visible. Now when I try to describe your JS UDF, let's see what result does it. You see my body content is hidden. All other specification parameters are visible, but my body is hidden. You do not know what actually this content is doing. And that is the purpose of the secure UDF. Okay, now you may say that, yeah, I should be able to get the DDL by running this get DDL command. And let's try that out. So the non-secure UDF, so I can see the entire content including the body. This is a non-secure, so it is expected. When I try to do the same thing for secure UDF, let's see what happens. Here, this operation cannot be performed. It means that you have completely secure your UDF and the body of the UDF is not visible. So this is what the purpose of secure UDF, and secure UDF is also used for data sharing purpose. We have covered the data sharing in earlier chapter. Please refer the link above or in the description below. Now let's change my role back to system admin and see how does it look like. So my role is system admin and now I am going to run the secure JS UDF. I'm able to see the result. So this is how the secure keyword makes a difference when you are creating a secure function. I hope this is clear to you. If you have any specific questions related to secure UDF and the role and grant, please put your query in the comment section, or you can also reach out to me in my Instagram account. Now let's quickly understand this null handling parameter or properties. Let me switch my context. Now I am creating a function called null handling SQL UDF. This is an SQL UDF. This is written in SQL, and I have specified the parameter called returns null or on null input. What does it mean? If the input is null, this statement should not get executed. Okay. However, what we have understood in a theory, even if you provide this property while creating an SQL function, this does not really take into consideration. And let's prove it by running it. I am creating another JavaScript function with the same property, and I run only when input is not null. So this is what I am expecting as a result. List both the functions. So all the parameters look same, except one is JavaScript and one is SQL. Now I am going to describe the SQL function first, and I see only the 4 result. Good. When I describe the JavaScript function, I see 2 additional things. One is that null handling property as well as the volatile property. The null handling property specifically tells that return null on null input. Now let's test this function. I am passing null value and non-null value to both the functions, and let's see how does it behave. So for SQL, even if I have passed null or not null, its behavior does not change. However, for JavaScript, when I pass a null value, it returns a null value. When I pass a not null value, it actually executes the expression. So now you know clearly when you should use JavaScript function and when you should use SQL function. Moving to our next topic, inbuilt versus custom function. Snowflake has many inbuilt functions, and let's understand their categories. There are more than 500 inbuilt functions in Snowflake, and they are classified under different categories like Scalar, aggregated, window, table, and system. To know how each of them work, you need to refer Snowflake documentation or refer my SQL playlist where many functions are explained with their purpose. Change my context and listing all the functions using show functions SQL statement. Now this has brought the result for all the functions which are available in the Snowflake in my account. So let me change all the query ID. We'll try to understand how would you view all those inbuilt functions in Snowflake. After I executed my show function, I got the query ID. I'm using result scan table function to convert those results into a table and apply some where and group by clause. My first group by clause says how many JavaScript function I have it, which is inbuilt. So I have total 585 SQL functions and only 1 JavaScript function. How many inbuilt functions are ANSI standard? Let's run that. So I can see total 483 functions are not ANSI standard, only 103 functions are ANSI standard. How many of them are aggregated, which falls under built-in category? So I have 77 aggregated function and 509 is built-in function, not aggregated function. Now, if I have to understand how many system functions I have it, so this is the query I can run. These are the system function, which is non-aggregated, non-ANSI, not table function, and they are applicable for clustering, and this is their argument. Now, if I have to understand that how many functions are really valid for clustering, in the sense, if the clustering is applied on your table level, functions are really take the advantage of the clustering under the hood. Let's check that. Upper function is valid for clustering. It means that upper function really takes the advantage of the clustering. And if you have not seen my clustering video on a chapter 13, I would really recommend to go and watch my chapter 13, which covers the clustering in detail. Let's explore the table function and how they are different from scalar function. Scalar function returns 1 row and 1 column. On the other hand, table function returns multiple rows and 1 or more columns. Like scalar function, the SQL table function also has similar construct, except the return type keyword has a table as a return type. In this example, we are creating a table function called myTabularUDF, and it does not take any input argument. The function definition returns multiple rows and multiple columns, and column count and the data type should match what is defined in the select SQL statement in the function body. A table function can be accessed using the table keyword from the from clause of the query. Let's see it in action. Now let's understand how to create a simple table function. I change the context. This is my simple table function, and if you pay attention, the only difference you will find it in this table function on line number 10. So it says create or replace table function my tabular UDF, and it returns, instead of returning a string or a number, it returns a table type object, and this table type object encapsulates the name of the column and the type of the column. The number of the column and the data type should match from your select expression from the function body. What this UDF is doing, this is actually firing a query through the result scan, converting the result into a table, applying the where clause, and returning all the inbuilt function which start with the system. Let me create this function. So my function, my tabular UDF, created successfully. Unlike scalar function, table function need a different keyword that is called table keyword, and we have to wrap the function call within the table keyword, and I can use it like this: select star from table followed by table function. If it needs any input, you can pass input. In this example, we are not taking any input argument. So let's run this. So I got all the inbuilt function where the name start with the keyword system. Now when I describe this table function, let's see what all properties and values does it display. So the properties and values are very similar to what we have seen for a scalar function, except the return type. Whether you use JavaScript or a SQL function, they follow the similar approach the way we have seen for a scalar function. Only difference you will see in the return type. The return type here is a table type which has a column name and the column type. Now let's see how the show function works. So here is the result. I have two table function, and how do I know whether they are table function or not? I can go and check this column. If the flag is yes, it means it is a table function. This is how you can create a table function. All the properties what we have applied in a scalar function is also applicable in table function. I am going to create a separate video which primarily focuses on table function. And for this video, we'll keep the scope limited. Important points to remember for table function. The main body of SQL user-defined table function must be a select expression. The SQL select statement does not end with a semicolon. We have seen even in a scalar function. Tabular function UDTF have a limit of 500 input argument and 500 output columns. Very, very important things to remember. In many projects, we have seen there are 500, 600 and 700 columns. So make sure that if you are trying to fetch a lot of columns from the user-defined table function, this is one of the limitations. When calling a UDTF, in the from clause of a query, specify the UDTF's name and argument inside the parenthesis that follows the table keyword. Example, select star from a table followed by your table function name followed by the argument. Next, we will look into how we can overload our user-defined function. Snowflake supports overloading of SQL UDF names. Multiple SQL UDF in the same schema can have the same name as long as their argument signature differ either by the number of argument or by argument type. Let's understand this concept. Here we have two functions with the same name and both having two input parameters. However, the data type for the input parameters are different. This is a very simple example. You may find many use cases where you would like to apply overloading approach to handle different business scenarios. Let's see them in action. So my context is changed. So this is my first function which is taking two parameters and data type for both the parameters are number, and it executes this SQL statement where it is adding these two numbers. So this function is created. Now in the second case, I am using the same name. I am passing again two parameters, but both the parameters of data type varchar. Now let's create it. What happens when I call this function? So first function returns 10 for these two inputs, and the second return 55. Well, this is a very trivial example. So you will find many use cases where you will prefer to use function overloading or a method overloading to satisfy your business need. Now let's explore how you can create a user-defined function using Java programming language. For this demo purpose, I am going to create a very simple Java class which returns a random number every time you invoke. So this is my Java class, and don't worry about a lot of lines here. It is simply creating a variable called x. It is assigning a random value to x, and when you call this method handler, it returns that random number back to you. That's it. What we are going to do in our live demo, we will compile this Java class. We will make a jar from that class, upload the jar into the stage location in Snowflake, create the function using that jar file. So these are the 4 steps we are going to follow. This is my Java class. Start with a keyword class and open bracket and close bracket. You have to write everything inside that. I have created a variable called x of type double. By default, this value will be 0. So I am instantiating that variable when this class is created, and I am assigning math.random. This random will return a random double value. And whenever somebody calls this method myHandler, the same variable is returned. So this is the primary objective, is the Java class. Fine. I'm going to compile my Java file using this command javac myjavaudf.java. Now I can see my Java file is compiled and it has produced a Java class myjavaudf.class. Looks good. Now let's run my Java class and see whether it is giving that random number or not. Every time I run my Java class using command java followed by my Java UDF, and I don't have to give the dot class, it automatically look for dot class file from that location and it is giving me the appropriate result. So every time I run this class, I get a different result because it is producing a random number. Now I am going to create a jar file using this dot class file. For that, the command looks like this: jar -cvf myudf.jar. You can give any name like my function.jar or demo function.jar or anything, followed by the name of the class. In this folder, I have only one class. That's why I have specified star.class. You have to give, alternatively, you can also write the name of the class like my java udf.class. However, if I have only one class, the jar file will consider only one file and it will package them. Now you notice my udf.jar is successfully created. And this is how my jar file looks like. Now I am going to execute put command to put the file inside my stage location. For that, my command goes like this: put file followed by the file location where my jar file is available and @tilde/java udf, and it will move my Java file to stage location. Here we have made one mistake. When we move this file to the stage location, it does the compression automatically, and this time the compression is gzip. So we have to make compression equals to false and run this command. One important thing to notice, when I tried registering my udf.jar, which was compiled on JDK 18, it started complaining error. The targeted Java version for Snowflake function is JDK 11. So I recompiled my jar with JDK 11 and then I tried registering the jar with my function. So now first list whether my jar is available in my location or not. For that, I am going to list my user stage location using the list command. So I can see my UDF jar is available. By default, in a put command, compression is true, and that's why I first got my jar file loaded as a gzip. However, I changed it to compression equals to false and got my jar loaded with my udf.jar file. So now this jar file is available. Now let's understand how I can register my jar file. It says create function my java udf. You can give any name. Returns double because that random number is giving a double, and language is Java. And here you can say import the location of the jar file and what is the handler. So that should be the name of the Java file followed by method which is handling this function. Okay, let me create that. So I got my Java UDF created. Let's describe this function. Now you can see the property looks very different when it comes to Java functions. Here the language is Java, return type is float, null handling called on null input. Okay, so it can take null. Volatile, the body is empty because it is wrapped inside a Java file, and import is this particular location, handler is this location, target path, runtime version and packages. So this is how my Java file packages looks like at very high level. Okay, let's call this. This is the function looks like, and if I call this twice, every time it should generate a random number. You see the behavior, right? Okay, though I called this Java function twice, it is actually returning the same value. Let me try this way. So now this time I can see this Java function is returning a two different value. Now let's list the function. So if you do not provide any description, it always takes user-defined function or user-defined procedure in case of procedure. And here I can see my language is Java. This is how you can use Java function in Snowflake. Let's discuss some of the important points we need to remember when building solution using user-defined function. Snowflake does not validate JavaScript code at UDF creation time. So make sure that you constantly validate your function when building a complex logic. For SQL function, the not null clause is not enforced for SQL UDF. We have seen this during our live demo. Function definition or a body has size restriction. The maximum allowable size is subject to change. So what does it mean? That don't write a very complex and large and big SQL functions or JavaScript function because it has a size limit. And you never know that after writing such a complex logic, you are not allowed to run them in your Snowflake environment. If using a UDF in a masking policy, ensure that the data type of a column in UDF and masking policy matches. The delimiters around the function definition, or we call it function body, can either be a single quote or a pair of $sign. SQL UDFs defining expression can refer to other user-defined function. However, it cannot refer recursively to itself, either directly or indirectly. The expression defining a UDF should not contain a semicolon as a statement terminator. The UDF owner must have appropriate privileges on any database objects that the UDF accesses if the function has SQL expression. For a non-table UDF, the query expression must be guaranteed to return at most one row containing one column. Defined functions are well-known concept in the database world as well as in the big data world. This video just highlighted the basic SQL construct, how to use the standard SQL script, JavaScript, and Java programming language to build the user-defined function, including its important limitations. Our part 3 of episode 21 will deep dive on standard, secure, and materialized views, their purpose and their limitations. Views are also a very common concept in the database world, but don't miss the next section. It will focus more on differences and features which are specific to Snowflake, including serverless concept when it comes to materialized view and its costing component. I hope you have been enjoying this Snowflake learning series, and if there is anything you liked in this session, please press the like button and leave a comment. So happy learning.